everyone. So my name is Toma Puljak, and as said today, I'll show you how to solve the but it works on my machine problem with cloud-based development environments. The first thing I must say, it feels so great to have my first international talk at such a great conference, and I'd like to thank the host for organizing such a wonderful event. I know we all had fun the first day, and I hope we'll have fun this last day. So a bit more about myself. I turned 22 a couple of days ago, but I've been active as a software developer for the past 5 or 6 years. I've been working at Code Anywhere as a software developer for the past, I think, 3 or 4 years, where now I'm part of the core team for B2B integrations and ID customization. I'm also a computer science student, and I'm missing my final exams right now because, you know, priorities. So I'm here holding this talk instead of writing my exams. Today, I'll talk about how to set up an environment that, once configured, can be instantly reproduced by anyone on any machine. We'll also see how to leverage this knowledge to create a seamless onboarding experience and how to enhance your current development workflow. We'll also see how to set up this process to be fast, secure, and most importantly, that it works on any machine. Okay, sorry. But why should you even care about creating such a seamless onboarding experience? Well, research shows that companies with a great onboarding experience see an improved employee retention by a staggering 82%. I believe this is a reason enough to maybe reevaluate your current approach and apply some of the things I'll talk about here today. I'll start by taking a look at the classic approach to onboarding I like to call the usual. I considered calling it the boring, but that was a bit too offensive, so I just went for the usual. Before I tell you what I think the usual looks like, I'd like a raise of hands to you who had a bad onboarding experience or ever said the phrase, "it works on my machine." Okay, I see a majority here, I think. For those of you who didn't raise their hands, you're either lying or you just work at wonderful companies, so great for you. So the usual, it's step 1, clone your project locally, and nothing really exciting here, right? Step 2 is open the README file that's often present in all these projects. Step 3 is you start executing some installation script or going through all the boring setup steps from that README file. And step 4 is the script or installation fails. And there's a number of reasons this installation step might fail. Maybe your OS isn't updated, because I know we all snooze that update button for at least 6 months. You have the wrong language runtime installed locally. It's not in sync with the one from the project. You have, I don't know, .NET 6 installed, but the project requires .NET 5. Or the script is simply outdated, because we all sometimes forget to update the appropriate installation steps when running something locally. And you move to step 5, which is you try to fix it. You spend a couple of hours trying to work around the installation, so you update your OS, you finally take the time and update that Windows or Mac or Linux. You install the right runtime this time, you sync it with the one the project requires, and you add what's missing in the installation because you somehow figured out what's missing and add it yourself. But it still doesn't work. And that's the most likely scenario, of course. And that's why you're here, I hope. And so you move on to step 6. You failed to set everything up locally, spend the day on it, so you just cry for help to your colleague. You see they're working on their projects on their machine, so they should be able to help you out to set it up on yours. But this is where step 7 comes, and step 7 is where your colleague starts to share your frustrations because he can't set up the project on your machine because they don't know what your machine requires. So they say the feared phrase, "but it works on my machine," and you just left to fight the battle on your own. Nothing left to do here, but flip your table, go back home, and hopefully you'll get lucky tomorrow or the day after. So you spend a couple of days working around it, setting everything up, updating OS, dependencies, and stuff like that. And you finally succeed. The setup completes, and you can finally start coding. You can see how this process can leave onboardees very frustrated. And I just felt bored even talking about it, spending this much time talking about this. But not only this, your company and yourself are wasting resources because of it. You yourself are not contributing to the company or the projects while spending hours or days trying to set everything up. You're bothering your colleagues who are moved away from their work because they should help you out with the setup. And if you're here thinking this is a one-time thing, this is not a one-time thing. Every time you move from a project on a weekly or monthly basis, or you just want to help someone out or contribute to open source, you're left facing this problem and wasting so much time installing everything and setting everything up. And now, let's see what a great onboarding experience should look like in one I call the new. It's step 1, click a button. It's step 2, start coding. And let's take a look at this again. It's step 1, click a button. It's step 2, start coding. You'll see, I'll show a demo example of this. You'll see that an environment set up like this takes less time than actually just talking about the usual process. Okay, so let's see a video. It's step 1, click a button, like a link in GitHub. Is the video rolling? No. Okay. So you click a link in GitHub, the environment is instantly built and configured. You're instantly redirected into the ID loads, a file you're meant to see for the first time automatically opens, and you can actually start coding right away. It should always be as simple as that. Now let's take a look at how to make all of this possible. Let's start with the configuration of this environment. To understand the configuration, we must first understand the concept of infrastructure as code. And infrastructure is really a hard word, so if I'm mispronouncing that, I'm sorry. And IAC is just the managing and provisioning of infrastructure resources through code rather than clicking some complicated UI or web interface or something like that. The beauty of IAC is that the file of your infrastructure can become part of your source code and thus be fully version controlled. Suddenly, you always know what's inside your infrastructure, why it's there, and why it changed over time. And IAC is not a new concept. Using tools such as Vagrant, for example, developers can provision development environments inside virtual machines with all the dependencies you need to run the project pre-installed on that machine. And while virtual machines are a great step towards solving that but it works on my machine problem, there are still some obvious drawbacks. Like virtual machines take quite some time to actually install and set up. And that's why developers tend to reuse the same pre-built virtual machines instead of creating new ones. And also, virtual machines are pretty heavy on your local environment, and you're probably going to get away with running just one. And this is where container technology like Docker, for example, come into play. And because containers are not virtual machines, there's no emulation layer, so they can just run at native speeds on your OS. And this technology will allow you to create consistent development environments tailored specifically to your projects. And they can work on any machine, and once configured, can be reproduced by anyone. Okay, so let's see an example. Docker Compose is a prime example of infrastructure as code, and most of you here that use Docker probably are familiar with Docker Compose. And Docker Compose looks something like this. So basically, the entirety of our project development environment infrastructure defined as code and fully source controlled. So let's say I have a development environment installed locally on my machine. I'm pretty satisfied because I managed to get it working by setting up a configuration file, and everyone from my company can actually work on their machine. I notice in the console locally that it says I have an outdated MySQL version, for example, for my database. It's some security patch that always comes up, of course. So I update MySQL, I modify some data, I change a few tables. I do so by executing some scripts locally to modify the MySQL version. And suddenly one of my colleagues can't even start the project because of some database error, right? And I noticed that my environment changed actually quite a bit since I first started working on this environment. I updated MySQL. I did so by running scripts locally. And that's because I kept reusing that same environment again and again with the updates I bring in. So my colleagues who are using the exact same environment are not seeing those changes, and they can't run the project because their environments are not fresh. And to fix this problem, I'll introduce ephemeral development environments. And ephemeral is kind of a sketchy word, but it just means something that lasts for a very short time. And they're quite common in the DevOps workflows. You probably notice them without just registering their ephemerals. So when running environments on a PR that test code or run integration tests, these environments are ephemeral. And what makes them ephemeral is that they just destroy themselves when they're done, and they give you their output, and that's it. And ephemeral environments are not just a fancy new concept. They represent a whole new approach to development. And in this approach, the idea is to, when you want to contribute to a project, you spawn an environment with everything you need to run, like opening a pull request or contributing to some open source code or just helping out a colleague. Once you're done, you just toss the environment, release all its resources, and that's it. That's the magic of ephemeral environments. And the power of it is that you can do this process any number of times. It's guaranteed to work, and it's guaranteed to be the same every time. Okay, so let's see, now that we've covered the theory and boring part, we can see how to set up an actual development environment. Consisted of, let's say, Rust for a language runtime, MySQL for a database, and a Redis cache store. So this is what the configuration file would look like if you're using the Code Anywhere platform. And you'll probably notice that it looks pretty similar to the Docker Compose file I showed earlier. And that's because it is. We wanted to create a configuration schema that's really familiar to a lot of developers, while still giving us the freedom to expand on some features like tasks, for example, which I can cover in the end if I have the time. And of course, the most important part of the configuration are services, which are just container configurations similar to Docker. They have their name, their image, resource limits like CPU and RAM, environment variables, and volume mounts. Basically, everything your container needs to be able to run specifically for your project. And here's an example of how to configure a Rust container. So with these couple of lines of code, I've defined a container for my Rust language runtime that has 2 CPU cores and 8 gigs RAM. Similarly, the database has 1 CPU core, 4 gigs of RAM, nothing special there, but I've included the required environment variable that defines the MySQL root password. And this is always a great password you should definitely include in your projects. Moving on to the Redis cache store, it's pretty similar again to the Rust language configuration with just the updated image and resource limits. And with this simple file configuration, I define everything my project needs to be able to run on any machine. And now all of my colleagues and myself can spawn this environment any number of times. It's guaranteed to be the same. It's guaranteed to work every single time. And this is what infrastructure as code is all about. One file defines the whole configuration, the whole infrastructure, all of the dependencies. It's fully source controlled, and it just works. I think this is just awesome. Okay, so that's the configuration of the environment. But you'll soon notice that if you run this whole environment locally, your laptop might start burning up. That's because this whole environment running at full capacity will run you 14 gigs of RAM, and 4 CPU cores. I know that's quite a load, and I know my laptop can't even handle it. I always say that I can cook eggs in the morning on my laptop when developing our projects locally. And companies have a solution for this. Companies tend to give you a strict list of machines you can buy with the most absurd specs and, of course, a steeper price tag. And I think this is not the solution. The solution shouldn't be to restrict your choice as a developer to any machine. You as a developer should be comfortable using any machine you want, even if it's a 2015 MacBook Air with 8 gigs of RAM. If you're most comfortable on that machine, you should be able to work on any projects you like. And this is where the cloud comes into play. And I'll show you now how to make these ephemeral environments cloud-based. When moving the environment to the cloud, we can utilize the basically unlimited resources it offers, but still keeping that local look and feel. Using tools such as Kubernetes or any container as a service solutions, you can tie this whole environment together and easily deploy it in the cloud. And this cloud-based approach, ephemeral cloud-based development environment approach, relies on tooling like this to make it as fast, as scalable, and as secure as possible. And now that I mention it, what about scaling? How to scale these environments? Well, if we were to scale our local development environment, our laptop, that has 16 gigs of RAM and we want to add 16 gigs more, because laptops today aren't meant for scaling, right? The only solution to this is to toss the laptop and buy a new one with the upgraded specs. This, of course, takes time, takes resources, and it's not really environmentally friendly, right? And with cloud-based development environments, ephemeral environments, what if we wanted to, let's say, add 4 more gigs to our database container? The solution to this is, again, toss the environment, which works because it's ephemeral, and get a new one updated in literally seconds. All this takes is one simple value change in the configuration and a couple of seconds to update the environment, and that's it. That's the beauty of infrastructure as code. Okay, so we've covered the scaling of these environments, moved them to the cloud. But how secure actually is this approach? I mentioned a couple of times this is a fully secure approach. But how is it so secure? Well, because these containers or these environments will run on your cluster, on your server, wherever you want to host it, you're in full control of all the input and output streams of all the data of that cluster. You can VPN this, you can firewall this, toss 10 firewalls to this, and make it as fully secure as you want. And moreover, each of these environments themselves are isolated by design. That means you can have multiple teams running multiple projects inside the same cluster while not worrying about leaking code between them. And the best security feature is that all of your code stays right on your servers, your cluster. There's no more laptop security management, wiping hard drives. If you want to revoke someone's access, just remove them from the network and that's it, you're done. And that covers the security briefly. And the last thing left to talk about these amazing features is how to code inside these environments. So we set it up in the cloud, how to connect to them. There are 2 approaches to this. The first being you can SSH into these environments. Just use your local favorite editor like any JetBrains editors, VS Code with their extension, for example. And I'll show you how easy it is to set up actually. So this is the JetBrains Remote Gateway plugin. You just enter the SSH credentials when you spawn the environment. And JetBrains, and you choose your favorite IDE, like IntelliJ, for example. The IDE takes care of installing everything in the environment. You don't have to do a single thing. And you'll see it connects really, really easily and really, really fast. And you'll see how to keep that local look and feel while using those powerful cloud resources to run the whole project. The other approach is install a browser-based IDE into these environments. This will basically allow you to code on anything that has a browser, like an iPad or Chromebook or anything else. And we at Code Anywhere actually installed the TIA IDE into all the environments because it's highly customizable. It's really VS Code, like it supports the whole ecosystem. We also developed some features like previewing applications or powerful real-time collaboration. And not only are the files collaborative, we also made the terminal collaborative because working together on bash scripts is fun when it doesn't work. And we also enable chat in the IDE because we believe that enabling collaboration, full collaboration, means never having to leave the IDE. You should only focus on your code and pair programming, helping colleagues out, everything within the IDE. And that covers the idea of this approach. This all looks great, it looks simple enough, but there's a lot of moving parts that go into this. And at Code Anywhere, we created a platform that's truly seamless. All it takes is that one file, that one button, and you get a fully featured environment working in seconds. And now for my final demo, let's see all of this in action. So if you move back to our previous Rust example from before, you'll notice that it connects simply to some MySQL database working in the environment, and it outputs some code. So to run this example, I just do what I do locally. I open up a terminal, run the start command, cargo run in this example, and I see a MySQL error in the console. That's because the database is missing. I actually forgot to include it in the configuration. So I just quit the environment, go back to GitHub, and I'm showing GitHub editor here to just show you how simple it is to update the configuration and get an updated environment. I update the environment variable for MySQL and name the database some name. I actually include a commit message because I'm trying to be a good developer. So I commit the changes like add database to MySQL. I move back to the homepage of the repository and click the exact same link I clicked before. This will create a fresh environment with the updated configuration. And as you'll see, our app will successfully connect to the database that's now present in the environment. So the file opens the exact same way. I open up the terminal. I input the same start command to start the application. And as you can see, the output is clearly shown. The database now works. And all it took was a couple of seconds to edit the file. But most importantly, this can now be used by any of my colleagues, any of my friends or contributors, and it's guaranteed to work on any machine. This is the next step in the software development evolution, basically. And we're not the only ones to think so. Companies like Microsoft and GitHub are entering the space with dev containers and code spaces. If some of you were at the GitHub keynote, you might have heard about it. But the true beauty of this next step of evolution is never install anything locally again. Developers should be developers. Don't focus on installations, spending hours or days setting projects up just to contribute a couple of lines of code to open source or to open any project in the company. Don't be scared to open projects and onboard. So the main takeaway of this talk should be step 1, click a button, and step 2, start coding. Thank you.
Thank you very, very much, Toma. Now, time for a little Q&A. I have some questions for you.
Shoot.
One of the questions is, what if my dev environment requires a large database to work, like 100 gigabytes?
Okay, so if your environment requires such a large database, there are 2 options. One, you can get the large database into all of the environments for all your employees or colleagues. The other option is just use a shared database. You can connect to an external database from all the environments and just use it, because I assume you're using the shared database right now. So if you're using it right now, it will work in your new development workflow.
All right. So another question to upvotes. What does this service offer to developers other than CodeSpace doesn't?
Okay, so that's a question we get 20 times a day at our booth. That's right down there. So we tend to focus more on businesses and business integrations. We're vendor neutral. There's no lock for GitHub. You can use any provider you want. You can install this on your infrastructure, your cluster as a platform. So it's really about, I mean, I'm not gonna lie, it's pretty similar to GitHub Codespaces in the feature sense, just that we focus more on business integrations and we're not vendor locked, so.
Okay. Could you give an example why you would need to scale a development environment?
You would need to scale. Okay, I actually now remember I forgot to say the sentence for that slide. So the sentence is, all projects tend to grow in time. And because they grow, so do the resources needed to run them. I don't know if you need to see the database really aggressively, you might need a database with a bit more RAM or a bit more CPU or a language runtime. If you're running multiple threads or something like that, you need to add configurations. Or if you just need to add some more dependencies into the containers and then scale them because of that.
Mm-hmm. Any experiences on Android development with having an emulator besides the IDE?
Emulation is also another question we get a lot at our booth and conferences. So the problem with emulation, Android probably can be done. We're not exploring so much in that space right now, but we have some few ideas using like VNC and tooling like that to actually emulate in the environment and then show the emulator as a link. But we're not quite there yet. You can come to our booth and speak to us more in depth about that.
Another very valid question. What happens if I'm offline? For example, on a plane, on the beach, up in a mountain?
Yes, okay, so if you're offline, you're out of luck, of course. But this new evolution steps assumes that you are connected, because I mean 95 or 99% of the time we're connected to some internet connection. But for that 1%, you unfortunately will have to use something local because these environments are in the cloud, the resources are in the cloud, so you need to connect to them somehow.
All right. What about that one? How can I see my desktop app that I am developing?
Okay, so desktop. First, you can't run any Mac apps, of course, because Apple is so tight with its regulations. But if you want to run like Linux desktop applications, again, the same principle applies to Android development using some VNC tools. It could be possible. I just don't have a live demo of that currently, but we're exploring that space heavily because we see it's a requested feature, of course.
All right, I would say due to time restrictions, we're at the end. If you have any further questions, feel free to reach out via Hubilo app or on Twitter, whatever, what you know. Thank you very much, Toma, for this
Thank you for being
talk.
here.